All right, so you'll notice that we've moved on to the back side of your notes, and instead of just having one inequality to graph, we have two of them. So I'll start with the top one. I'm going to do the work for it in red, and first of all, change to an equal sign. We'll have to solve for y, subtract 2x from both sides of the equation. And that will give us negative y equals negative 2x plus 3. Remember that you cannot leave the negative in front of the y, so we'll have to divide every term by negative 1. And that lets us have a positive y equals, now a negative 2 divided by a negative 1 is 2x, and a 3 divided by negative 1 is negative 3. So your slope is 2 over 1. Might write that as a fraction. Your y-intercept is negative 3. And so this graph will start at 0, negative 3. Also, you want to pay attention to the original problem, which had a less than or equal to symbol in it, which means that this will be a solid line. So if we move to the graph, starting at negative 3 on the y-axis at the ordered pair 0, negative 3, and your slope of 2, up 2, right 1. Because we're going to be drawing two lines, you definitely want to have an accurately drawn line. So put enough points on that you can see what you're doing. And this is a solid line. So we'll draw that line. And then I recommend that you go ahead and do your test point for this line just to see where that part of the shading is going to go. So your test point of 0, 0 will work. And I'm going to put 0, 0 into my 2x. So 2 times 0 minus y, so minus 0, is less than or equal to 3. And so this is 0 minus 0. We get 0 is less than or equal to 3. This is true. Now, I might not want to do my shading, but I at least want to know that it's going to shade in the direction where the 0, 0 is. The 0, 0 came out true, and so I want to shade in that direction. All right, so now I'm ready to move on to my second equation. Again, I'll write that one. I'm going to do this one in blue. So x plus y equals 2. And I have to solve that for x. So subtract x from both sides of the equal sign. And so that will give you y equals negative x plus 2. So you can find your slope is the number in front of the x, negative 1. I'm going to write that with a fraction. Your b, your y-intercept, is 2. So your ordered pair, 0, 2. We'll start this graph at 0, 2. We need to look back at the original problem. The original problem had a less than sign, which means that it's dashed. So when we draw this one, we need to use a dashed line. So it's going to start at 0, 2. Slope's -1, so down 1, right 1, down 1, right 1, and continue to put enough points on where you can draw the line. You can also go up and left. And following this pattern, you can draw that dashed line. Now, we'll need to also do a test point for this equation. I'll use a different color. So I'm going to use orange for that. And it's x plus y is less than 2. So if we test, so we're going to test 0, 0. 0 for the x and 0 for the y. And that will give us 0 is less than 2. That also gives us a true statement. So now I have to keep track of, I was testing it for the blue line. Here's the 0, 0, and that was true. So both of these are going to shade over where the 0, 0 is. And so I'm going to go ahead and shade this in. It's bounded by this dashed line and the solid line, covering up where the 0, 0 is. And this is what we call possibly super shading, where you have double shading, an overlap of the shading. So you find out where both graphs are shading, and you want to do the overlap, and wherever there is overlap, those are the solutions to both inequalities in that system. And so down at the bottom, we've got some points that we're going to look at to determine if those are solutions to the system. And one way that you can determine it is to just look at the graph, especially after it has been graphed. So if we check 0, 0, is 0, 0 in that shaded area where it was overlapped in shading? Well, 0, 0 was actually our test point. So yes, 0, 0 is a solution to the system. Now, another way that you could determine it is to plug 0, 0 into both inequalities and into the originals. So into the original inequalities and see if it makes them both true. In this case, it was true for the top one, and then I'll also check it in the bottom one. 0 plus 0 is less than 2. That is also true. If it makes both of them true, then it is a solution. So yes, that is a solution. Okay, if we look at the ordered pair 0, 2. So the ordered pair 0, 2, we'll find that point on your graph. Oops, excuse me there. So find the ordered pair 0, 2 on your graph. And 0, 2, I'm going to use a black marker for this, actually happens to be the y-intercept of the dashed line. It's right there. So 0, 2 is on the dashed line. And because of that, that means it is not included in the solution. And so therefore, this one is a no. And if you were to check it, 0, we can just check it in that bottom equation, that 0 plus 2 is less than 2. That's false. It was on the dashed line, so that 0, 2 is not a solution. Okay, then we'll check 4, 0. Now 4, 0 is, and I'm going to use a green dot for it. 4, 0 is on the right-hand side on the x-axis. So if you count over from where 0, 0 is, 1, 2, 3, 4, 4, 0 is not in the shaded area at all. So not in the shaded area, this answer is no. It is not a solution to the system. It's not in any of the shading. And so that is not a solution. You could also check it by substituting in 4. I'm going to put it in the bottom equation. 4 plus 0, or the bottom inequality, is less than 2. That is false. And so there's another reason why this is not a solution. Okay, we can move on to 3, 3. So the ordered pair 3, 3. So find where the x is a 3 and the y is a 3. And it's on the solid line, but being on the solid line and not in the shaded area makes that one not a solution. It has to be in the shaded area, even if it's on that solid line. So this one also is no. It's not in the shading. And that could be a reason that you could give. It's not in the shading. And then another reason that you could give is if you plug it into the bottom equation, it does not work. So I'll show that as well. So not in shading. And then the bottom equation, 3 plus 3, is not less than 2. So again, we have a false. And then finally, you have the ordered pair 0, -3. And that is the y-intercept on the solid line. So it's on the solid line and it's in the shaded area. 0, -3 is yes. It is a solution. Now, to be a yes, it has to make both of the inequalities true. So we'll plug it into both. 2 times 0 minus 0 is less than or equal to 3. And that is true. 0 is less than or equal to 3. And then 0 plus our y value was -3. 0 plus -3 has to be less than 2. Well, that's -3. And that is also less than 2. So that's a true statement. And 0, -3 is a solution. So when you're asked to find the solution, the easiest place to look is at the graph. But if you want to double check it, you can always substitute in. If only one of the statements is true, then that ordered pair is not a solution to the system. It has to make both inequalities true in order for the ordered pair to be a solution. So these are your examples for graphing inequalities and systems of inequalities. You'll be using Math Excel to do your graphing and shading, and I'm going to post a video on what that will look like for your shading.